Hello YouTube viewers, welcome to my channel S2T. In today's Rocket Monday show, we're going to talk about Copenhagen Suborbitals. So let's dive right into it. Now there is a very rare chance that you have actually heard of Copenhagen Suborbitals, but I have to understand, bring the story in front of you because this is the most amazing story about rocketry I've ever heard. Simply because this is a very small rocket company, as in 60 people kind of small, and they are non-profit, aka there are other rocket companies that make almost the same product as these guys do, like rocket from Rocket Labs, but they are non-profit, aka they are not making this thing to make money back. They're simply doing it, and they are crowd-funded, aka people like you and me are supporting them directly or indirectly. And their main goal, this team, this group of people that are working, their main goal is basically put first amateur manned space rocket, aka put a astronaut which is an amateur, basically no government support, nothing, just a dude and a space, that's it. And they're gonna make amateur astronaut into space. The now into space part is very critical because of their scale and scope. They know for a fact that they cannot orbit, so their main aim is basically what we call ballistic flight. Think of it this way: they are thinking of doing what Blue Origin is trying to do, basically launch a pod into what we call beyond carbon line and then fall back, ballistic trajectory. So that's they want to do, and they are 100% real and 100% serious. It's not a joke. It's not like, oh, many people have, like, dreams and all that jazz, and Wakanda aerospace and all that jazz, but these people are dead serious. Now, what is their rocket design? Well, their rocket design is what we call a Spicer rocket. Now, that's the name of it. They are gonna use an engine, BPM 100 engine. Now, if you have never heard of that engine, don't worry about it because that's in-house. They developed it themselves, and their size of the rocket is around 13 meter in terms of basically height, and in terms of diameter, it's 1 meter. So it's not a very big rocket, and their total weight is expected to be around 4 tons. Now, in terms of oxidizer, they are using liquid oxygen, that is the cryogenic part, and they are using ethanol plus water. And it's a Blue Origin smaller version. Blue Origin can do the same thing this puppy can do, only Blue Origin can do that with, like, 4 or 5 people. They are gonna do this with one person. Now, engine. Also, the engine is the heart of everything, basically every rocket system. So they developed it in-house. Why? One simple reason: because rocket engines are not something that you can just go and buy. And because due to national security and all that other jazz, there are other YouTubers who are actually working in the rocket industry, and they flat out cannot share the finer details of how the heck to build a rocket engine. So these people actually started to build their own. Now, okay, more than enough detail is available right now, and if you actually want to build a rocket engine yourself, go to a museum of rocketry, and you will get more than enough experience how the heck you're gonna actually build it. So they built it in-house, and the reason why they are mixing water with ethanol, it's first you have to understand this is exactly how the older rockets, aka V2 rockets, were used. Simply because ethanol burnt with pure oxygen, you're gonna get amazing performance. Side effect of that would be it's gonna be way too hot to handle by normal metal alloys. You have to have some high temperature metal alloys. Those are expensive. Because these people are crowd funded, they have to budget their stuff very carefully. So they are mixing water into it, and doing so has multiple advantages, one of which is a lower combustion temperature, another of which it also improves the thrust factor. So they're using that. Now, how the heck they're gonna run the rocket engine? Because again, you don't want a flamethrower, you want a rocket engine. So they are relying on pressure fed. Why pressure fed system? Because it's the simplest system. So basically they're gonna have helium or nitrogen, they're gonna basically pressurize the tanks. That's it. It's very simple. They were looking into basically turbopump structures, but so far the reality is very simple. Turbopumps will make the rocket amazing. Side effect: it is way more complicated than people realize. Even electric fed systems, even though they are much more cheaper, the battery banks required, the motors required, those are very expensive. So they are like just going with pressure fed system, and they are thinking of introducing a basically reheat system from the engine heat itself, so they can pressure maintain properly. So they are working on some ways of controlling it, but so far it's a very simple pressure controlled system. And they made BPM5. Now BPM5 was made based on this design. The reality of it is, when you want to build a rocket engine, you do not build the full rocket engine. You built a small one, they built a small one, they tested it, then they built an even bigger one, then they tested it, and they have already launched the smaller one into space basically. So they are not somebody who's like, oh, I'm gonna do this. No, they built it, they learned from it, and they tested it out. So in early designs, they wanted to use this kind of injector plate with micro holes. The reality was they could not drill this in, the BPM 100 engine properly. It was like too tedious, too complicated, too expensive. And you can see their rocket lab, quote unquote rocket lab. It's just a basically giant warehouse, nothing fancy. It's not even a clean room. So doing this kind of thing was way too impractical, so they went into swirl injector. And you can easily see like how they are progressing their design, how they are developing everything. It's like, oh, we thought we could use this kind of lathe to do this, it did not work out. They will figure it out how to do it again and how to solve it. The welding was the biggest issue for them. It's like you can get the steel that can handle liquid oxygen, problem is how the heck you're gonna weld it reliably. And you can have seen already how much trouble Elon Musk is happening, and that guy has like a multi-billion-dollar company working behind it. It's a tedious task. So they had to build their own quote-unquote robots that are gonna do welding, and then gonna own pressure testing to verify whether it's working or not. So it's quite amazing the things they are doing with their engines. Now, it's one thing to design something, test some things, but so far, what makes them very serious is basically they're not doing this one time. They have been doing this for a very long time. They started as early as 2010, and the first amateur rocket that they launched was Heat 1X. That was June 3rd, 2011. Then they launched the launch escape system. Basically, if they have a capsule, they have to have a way to launch escape it. So launch escape system was tested on 13 August 2012. Everything, brick by brick, they are testing it. And if once you see, like they already have their own drone ships for launching rockets from, because they do not get clearance from launching from land. So they are like, okay, we're gonna launch from sea. Every single aspect of it, like, okay, we're gonna build this rocket engine, we're gonna test it. If we're gonna build this staging mechanism, we're gonna test it. We're gonna build this parachute, we're gonna test it. Everything, basically they are 100% serious. And that's why I'm like, once you see how many testings they have done, how many rocket launches have there, how many engine minutes they have tested, then you start to realize, okay, these are not some quote unquote amateurs. They are amateur by simply because they are not getting paid for it. That's what amateurs mean in this context. Amateur is not like, oh, they do not know what they're talking about. Amateur simply means here they're not getting paid for it. So they have hundreds of small testing, like, including launches, including full rehearsal launches and actual launching of a payload. They have done that. It's just multiple small one, and they are adding up to building a full manned flight. And it's a doable task from their point of view. It's doable, and given the fact how many small success they have, they can actually do it. So this is the reason why I'm sharing this video with you guys, because these people are doing something amazing. What they are trying to do is basically remove the mystery of what we call as great science mystery. Because there are many times programming, let's say programming, many people have this idea, no, programming is this like, wall of code and hoo-ha, and I can't understand. There is a wall to that. Same happens with rocket industry. Heck, we use rocket science as like, the most complicated thing. Oh, this is not rocket science, so aka rocket science is the most complicated thing. So these people are taking that and tearing it apart. It's like, dude, it's rocket science, it's made by human, a human can do it. You want to support it, you can do it. Like, and everything they are doing so far right now, their success record is already higher than what basically in 1969 people had, flat out. And you have to understand this, the technology is so much cheaper, so much practical. Their electronic control circuit already is much more smarter than what Apollo guidance system had. So all this basically cheapening of the technology, and the fact that they can literally ask people, they can ask internet for, hey, we want to weld this, how the heck we gonna do that? And people supported them. It's like, dude, try this welding structure, it works and all that. There are people who are like, come in on off while once in a while. Basically somebody is like, hey, I'm good with tack weldings, I'm gonna do your tack weldings for this time, I'm free, I'm gonna do that. Because you have to understand that people are working for free. So there is like quote unquote 60 people team, and all of them have day jobs, all of them. So there is not even a single individual at this company which can be like, oh, I'm working for someone. No, none of them are. Like, this is a side project for 60 people who are like, who do their day job, and in the evening they spend their time in this project, or flat out their Saturday, Sundays, holidays and all that. So you can understand this is quite an amazing feat that so many people are coming to it. Like 60 people are not small, that's a big team. And all of them are like putting their heart and soul into this. And they are doing this as a side project with no hope of profit, nothing. And when you ask them, like there are many interviews of these guys, when you ask them why you are doing this, the answer is very simple: because it has to be done. Like, why somebody climbs Mount Everest? Because it was there. So I'm very hopeful and kind of mesmerized by these guys. It's like what they are trying to achieve, it's a very difficult, it's not a joke, it's a very complicated thing, but they are doing it. It's like, how the heck you gonna solve it? You do it. They are a poor version of Elon Musk, because even though Elon Musk started a company, he had $100 million, so at least he could pay some people. They do not have that luxury, and they are like, take Elon Musk and separate it into 60 people. So they are very simple folks. It's like you see them working in the lathe. It's not like some majestical hand with some like advanced measurement units. It's very simple. How the heck they are testing their flow rates? Just have a bucket of water. That's it. That's how they are testing the flow rate. It's like, I sent 100 liters here. How much I got in, like in this stopwatch? Okay, 100 liters in this. That's how they are doing it. Everything. And if you watch their YouTube channel, you spend time on it. Like you can literally see how a rocket comes together. It's like, yeah, is it the same as like Falcon 9? No, hell no. But it's the same principle. It's like if you can understand programming an Arduino, you can in principle program a supercomputer. Again, it will be much more complicated. It will take much longer times, and it will be much more tedious. But you can do it. It's no longer that majestical thing I can't see through. They are bringing basically rocket science to Earth. So I'm very impressed by it. Like I'm mesmerized. That's why I'm sharing this basically video with you guys, because my main channel has 30,000 subscriber, but this channel has less than that. So it was quite of odd thing, because I want people to support it, because if they succeed, there is a very good chance they might become the fourth or fifth people to go into space. Because right now the only record holders are like Russia first, Soviet Union, okay. So Soviet Union, America, China, and India is supposed to be the fourth one, because our project is running on time. So if it actually launches, and their end game is like around in 5 years, aka 2025, they should be able to launch their manned mission. So let's see how things unfold. And I'm quite in awe, so to say. I'm quite in awe, like the amount of effort, the amount of what we call elbow grease they are pouring into this every design. They're like, okay, this is how the seat is gonna be. It's not very comfortable. They're like cannonball position, simply because that helps them to retain consciousness. The G-shock will not make you pass out, and also make sure the rocket is small. So amazing amount of effort, dedication from all these 60 people. And for the people who are like actually supporting it, like there are people who funding them, like the minimum funding is like $10 per month, and $20 per month, and or one-time donation. So many people are pouring their heart, hard-earned money into this. It gives me hope for humanity. Let me put it that way. It gives me hope for humanity. So this was a quite an amazing company that I wanted to bring forward you, and hope to give them some more basically notoriety, so to say. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.